Hi, myself Vivek Sundaram. Now I'm going to make a video on concept of limit, that is class 11th part. Basically, limit is a portion which comes under the calculus, and it is used to find the value of indeterminate format of function. Means a function which gives a value like 0 by 0, infinity by infinity, infinity ke power infinity, infinity minus infinity. So this type of function where the value does not come appropriately, so we can use the concept of limit to find the approximate value or to find the limiting value. As far as R.S. Agrawal class 11th concerned, all the question is based upon on 0 by 0 format. Okay, so let us see a function x square minus 16 upon x minus 4. Now if you put the value x is equal to 4, then what happened? 4 square minus 16 upon 4 minus 4. So we are getting 0 by 0 format. Okay, but can we write in another way? So we can write fx is equal to x minus 4 into x plus 4 upon x minus 4 and cancel out the common term. Then we are getting x plus 4. Now if you put x is equal to 4, then what we will get? We get 4 plus 4 is equal to 8. So this value is obtained by limiting approach. By cancel out the common term in numerator and denominator, then we are getting the value fx is equal to 4. We can write limit x tends to 4, x square minus 16 upon x minus 4 is equal to 8. What we can write? Limit x tends to 4, x square minus 16 upon x minus 4 is equal to 8. So this is limiting approach where we are cancel out the common term so that there is no term which makes the limit of expression 0 by 0. So our main objective in the limit is, if whatever the limit of expression is given, we must remove the term which makes the expression indefinite or indeterminate. That is the main objective of the this chapter, concept of limit. Approach of limit. Suppose this is the value a, so we can approach from right hand side and we can approach from left hand side. So here we have to put x is equal to a plus h, and here we can put x is equal to a minus h, where h is very small fractional value. If I talk about RHL, means right hand limit, then we can write limit x tends to a plus fx. A plus means the value of a is greater than a. So this is right hand part, and we can write limit h tends to 0 f a plus h. Similarly, in LHL, limit x tends to a minus fx is equal to limit h tends to 0 f minus h. This is right hand limit evaluation, this is left hand limit evaluation, and if right hand limit is equal to left hand limit, then we can say that limit x tends to a fx is exist. Then we can say that limit x tends to fx is exist. So this is approach of the limit in which we have to see regarding right hand limit, left hand limit, and whether the value of both the limit is equal or not. If it is equal, then we say that the limit of that function is existing. Working rule of limit. First, if limit of expression contain normal function, then we put x is equal to a. X is equal to a means whatever the value tends to as x is equal to a, then we can put. Like for example, limit x tends to 3 2x plus 3. In this question we don't need to analyze more. Just put the value of x is equal to 3. So 2 into 3 plus 3 is equal to 9. Okay. Second, if limit of expression contain rational function. Rational function means fx upon gx. Then cancel out common term. Then cancel out the common term in numerator and denominator, and then put x is equal to a. Then put x is equal to a. For example, evaluate limit x tends to n, x square minus 4x plus 3 upon x minus 1. So the above term numerator part is a middle term split. So we can write limit x tends to 1, x square minus 3x minus x plus 3 upon x minus 1, or limit x tends to 1, x minus 3, x minus 3 upon x minus 1, limit x tends to 0, x minus 1, x minus 3 upon x minus 1. Cancel out x minus 1, x minus 1. So limit x tends to 1, x minus 3 is equal to 1 minus 3, that is minus 2. So just put the value of x is equal to 1 after simplification. Third one, if limit of expression contain such, then multiply by it conjugate search in numerator and denominator, and then on simplification cancel out common term, and then put x is equal to a. Search mean like under root 1 plus x minus under root 1 minus x. Example like root 1 plus 3x minus root 1 minus 3x. The power of fraction is in the power of any expression. If it is fraction, then it's called surds. Okay. For example, evaluate limit x tends to 1, root 1 plus x minus root 1 minus x upon x. Okay, so this portion is surds. So how can we solve? Limit x tends to 1, root 1 plus x minus root minus x upon x into root 1 plus x plus root 1 minus x upon root 1 plus x plus root 1 minus x, or limit x tends to 1, root 1 plus x whole square root 1 minus x whole square, because a minus b, a plus b, x into 1 plus x plus root 1 minus x. So limit x tends to 1, 1 plus x minus 1 plus x upon x into under root 1 plus x plus under root 1 minus x. 1 cancel out. Limit x tends to 1, 2x upon x into root 1 plus x plus root 1 minus x. X cancel out. And if you put, sorry, the question is x tends to 0, x tends to 0, x tends to 0, x tends to 0. And if you put x is equal to 0, then you get 2 by 2 is equal to 1. Okay. Fourth, if limit of expression contains series, then use following formula to solve questions. First, limit x tends to 0, e to the power x minus 1 by x is equal to 1. Second, limit x tends to 0, a to the power x minus 1 by x is equal to log a. Third, limit x tends to a, x to power n, a to power n upon x minus n, a to power n minus 1. Fourth, limit x tends to 0, log 1 plus x by x is equal to 1. These are used in the first exercise of the RSL1. In the second exercise, the concept of trigonometric limit is used, where we have a formula like limit x tends to 0, sin x by x is equal to 1. Limit x tends to 0, tan x by x is equal to 1. Limit x tends to 0, cos x is equal to 1. These are the important formula which helps to find the solution of questions in exercise 1 in our SL1 class 11th limit chapter. So that's all about today's. Thank you everyone.